Okay, so we're gonna do some work with radicals and square roots and things like that. So here are just some common square roots, also known as aka perfect squares. Square root of 1, square root of 4, square root of 9, square root of 16. You know, a lot of these you probably should know. If you don't know them, it'd be a good idea to learn them, but I'm not going to spend a lot of time with them. So first off, we're going to talk about simplifying radicals. When we have a radical that not necessarily comes out even. Like we know square root of 25 is 5, square root of 16 is 4. So this one's probably 4 point something, maybe 4.6, who knows, something like that. But you've got to get used to simplifying these, not just coming up with a decimal every time. We're going to simplify these so we get the exact answer. And so what I do is I factor these out. It's like a factor tree situation. So 20, for instance, breaks into 2 and 10. 10 breaks into 2 and 5. And so that's a set of prime factorization. So this is 2 times 2 times 5. Well, 2 times 2 is 4, so this is really the square root of 4 times 5. Well, we know what the square root of 4 is from the perfect square list I gave you earlier. Square root of 4 is 2. So this is 2 times the square root of 5. So one way we do this, or I do this, or how I was taught, is you circle the pairs, which tells you your perfect squares. So the 2's pair up, square root of 4 is 2, so you end up with 2 root 5 for square root of 20. So let's try this again with another number. Let's say we had the square root of 48. Okay, so, pause the video, see if you can do this one. And I'll give it a shot, show you how it's done. So 48 breaks into 4 and 12, and 4 breaks into 2 and 2, 12 breaks into 4 and 3, 4 breaks into 2 and 2. So if you think about it, we've got a pair here, a pair here, with a 3 left over. The prime factorization was 2 times 2 times 2 times 2 times 3. So what we have really is the square root of 4 times the square root of 4 times 3. Well, we know the square root of 4 is 2. The square root of 4 is 2. The square root of 3 stays irrational, so the answer is 4 root 3. Okay, so that's the square root of 48. So let's say we had 5 square root of 20. All right, we've already dealt with the square root of 20, and we broke that down. That was 4 and 5. I'm breaking it down a little differently, 2 and 2, because it really doesn't matter how it's broke down. So you got a pair of 4s. So you have 5 times the square root of 4 times 5. Well, we know the square root of 4 is 2. So we know that's 10 square root of 5. Alright, so let's maybe do one more. So let's say we had 8 square root of 18. Alright, 18, so give it a shot. Hit pause, see what happens. So 18 breaks into 9 and 2. 9 breaks into 3 and 3. There's a pair of 3's. So essentially what's happening here is we have 8 times the square root of 9 times 2. Well, we know the square from the pair of 3's, that's 9. We know the square root of 9 is 3, but there's an 8 out front already. So we've really got 8 times 3 times the square root of 2. Well, 8 times 3 is 24, square root of 2. So that's how you simplify a square root and the radicals involved in a square root. The other thing they talk about here, and we'll deal with squaring radicals first. So let's say we had the square root of 5 squared. Okay. Well, the square root of 5 squared is really the square root of 25, which is 5. Notice how the square and the square root cross each other out. So you're simply left with the 5. But I really did this. I followed the rules of exponents there and said, well, square root of 5 squared is really square root of 5 times the square root of 5. Well, when you multiply those, that's the square root of 25 like I had here. And the square root of 25 we know is 5. Oh yeah, I was supposed to avoid that. So if you had, say, 2 square root of 3 quantity squared, so the quantity of 2 root 3 squared, in this case, I would write this out twice. For some reason, this is the crux for my geometry students. They really struggle with what do you do when you square an irrational number like this. Well, you just follow the normal procedure for squaring. So 2 root 3 squared means you write it out twice and multiply it. So 2 root 3, and when you multiply radicals and numbers multiplied together like this, you kind of keep everything stuck together. So you multiply the numbers and numbers, which would be 4, and then you multiply the roots and roots, which would be square root of 9. Well, we know square root of 9 is 3, so this is 4 times 3, which is 12. So that's how you multiply an irrational number like that. The last thing for rationalizing denominators of a square root is, this one is probably the hardest one. You also want to know why we do it. I did a video on that earlier. But essentially it's this. If you have the square root of 5/3, for instance, alright, we need to figure out how to rationalize this. Well, first off, this is the square root of 5 over the square root of 3. And again, I showed you how to simplify that in a separate video. So for now, we're just going to simplify it as we don't want a radical in the denominator. So this square root of 3, we don't want it as square root of 3 anymore. What's nice is we can just multiply by that root 3 on top and on bottom, because square root of 3 divided by square root of 3, that's 1. So we've made this really nice 1 there. And just multiply straight across. So that'd be square root of 15 divided by the square root of 9. Well, we know the square root of 9 is 3, so the answer is square root of 15 over 3. And again, I showed why that's important earlier. So let's do another one of those, just so you know what's going on. So let's say we had the square root of 8 over, I don't know, let's do 7. Okay, first off, I would pause the video and see if you can do this problem. That would be the first thing you should do if you've never done them before. So let's say we did this. So this is really the square root of 8 divided by the square root of 7. Well, the square root of 8 we could simplify. Square root of 8 breaks into 4 and 2. 4 breaks into 2 and 2. We have a pair of 2's, which goes out front. So in the top we have 2 root 2, and on the bottom we have 7. The pair came out front, just so I'm not confusing you, because that seems to be the biggest issue. So 8 is the square root of 4 times 2. Well, the square root of 4 is 2. This root 2 stays a root. So that's where I get the 2 root 2. And that, for some reason, is a big sticky issue for kids. So let me go back to this. Again, that square root of 7 should be square root of 7 over here. So to eliminate the square root of 7, you'd multiply by square root of 7 on the bottom and the top. Well, you only multiply powers or roots and roots and numbers. So on the top, you'd have 2 root 14. On the bottom, you'd have root 49. Multiplying these two together, multiplying these two together. Well, root 49 is 7 on the bottom, and 2 root 14 stays as is. So that's the simplified version of the square root of 8 divided by the square root of 7. So that's some just general stuff with radicals. I hope it helps, and I'll see you next time.